Well, if you're like a lot of Americans, they wondered about the militarization of the police force. And a lot of people said, yeah, there's terrorists in our country. They, uh, they get automatic weapons. The cops should have automatic weapons. They need the armored vehicles because I was in the infantry and I know if you're going to assault a target with a bunch of terrorists holed up in a federal building, a school, or some other hospital or something, you need some armored vehicles to protect you while you take small arms fire. That's all true. There are some other uses for a vehicle, and a tank, even M1 main battlefield tank. You don't need the cannon probably for most ground combat in the United States, but there could be an occasion where the National Guard get called up to quell a rebellion that involves a substantial number of people. And a tank could be useful to take out, say, a terrorist stronghold or something. But generally, what I would see it as useful for is EOD, Explosive Ordnance Disposal of a weapons of mass destruction. A tank or armored vehicle could serve as a useful containment vessel. What is a containment vessel? In nuclear power, nuclear security, and nuclear weapons, you start out with a little training in health physics to keep you safe, right? The things you learn first are time, distance, and shielding. Reduce the amount of time you're exposed to your radiation, to your ionizing radiation. Distance. You increase the distance between you and the radioactive source to the extent that's possible to do your job. So you want to minimize the amount of time and distance that you're exposed. You maximize the distance, minimize the time. They call that a LARA, a low as reasonably achievable exposure, right? They're referring to exposure. And shielding is just putting barriers between you and the radiation. Out at the nuclear power plant in St. Lucie County and every other nuclear power plant in the country, let's not talk about the research reactors. Primarily, I'm talking about the ones, and not the naval reactors, the ones out there on the border up and down the East Coast, and a few that are scattered around the country. Most of them along the East Coast that provide a good portion of our electricity. Not 76% like the French, but maybe a quarter of our grid capacity comes from nuclear. Well, there's something called a containment vessel. And what is that? Well, if the reactor gets too hot, what does it do? It melts down, right? What is melting down? Well, when it gets too hot, it will burn through the concrete. It'll melt the concrete, right? Because everything at hot enough temperature can be converted into what? A liquid or a gas, right? So concrete at a hot enough temperature will melt down and become a liquid. Some of it could turn into gaseous material too. When things burn, they give off carbon dioxide and water in the form of steam. This is a kind of gas, right? So it's a meltdown, right? And what is causing it? Well, it's too much heat. It's a reaction in there. There's fission going on in a reactor that drives a steam. It creates a steam that runs a turbine that generates electricity, right? So the electricity in the steam is not going to cause the reactor to melt down, but it's all that nuclear power that gets hotter and hotter and heats it cooling up toward the point where the planet ain't cooling no more. The turbine and all that and shit is not cooling. It'll melt the concrete and the radioactive gases and dust and everything else will escape. It'll spew waste everywhere or whatever. And it'll melt through that concrete. And there's a thing over the top of those things. You see it. It's a big thing. It looks like a dome. Like a kind of a big... it's not a geodesic dome or anything, it's just kind of like a big capsule that goes over the top of those things. That's the containment vessel. It keeps the dangerous materials inside, supposedly. It's supposed to. Well, there's also gases in there, right? Because there's hydrogen gases that are called deuterium and tritium, right? You may have heard of them. And they're radioactive gases. They can explode, blow up the plant, and send everything sky high. How does it all work? Well, there's uranium fuel rods, right? And you have neutron radiation source that bombards the fuel rods, right? And if the neutron just slams into the rod, it be going too fast and it won't bond to the uranium. And why does it have to bond? Well, you have to bond it. So you get 236, and 236 is unstable. 235 uranium is a good fuel rod, but it doesn't create spontaneous fission because it's stable. So when it becomes unstable with that extra neutron, at 236 it's unstable, it'll split into two. Fission is like division. Fusion is where you fuse two things together, you like welding. And fission is where you split them apart like an axe or what you would on some wood or a log splitter or something. Fission is division, right? It divides it in a couple parts. It's usually two radiation products, right? Two fission products is what they call it. And they're both radionuclides, ionizing radionuclides, and three more neutrons, right? And then all sums back up to the mass will be 236 still. But you got this other stuff. So how do you slow that neutron down? You got a moderator. And the moderator in the Navy reactors is all pressure water reactors, right? In the submarines and aircraft carriers. In plants, you have graphite core and all these other things they talk about, heavy water, light water. Oh, you can go look at Wikipedia. It'll tell you how a nuclear reactor works and what the different types are and what the difference is and what a moderator's for. And you can cross-reference other pages like about the fuel rods and nuclear enrichment and things. You can figure out how a weapon works. Well, one of your best sources for how a nuclear weapons work is those guys at Harvard. There's a reason in the movies they say they're a bunch of terrorists. In Harvard, you can learn it. You might not learn it in the classroom in a physics class, but you can log on to the Belfar Center or something like that, and there's a professor who has some videos about how to build a nuclear weapon. It's educational material that's available on the internet, and they make it a little easier, a little more accessible, and they can figure out who's looking up that kind of information as well. And most people who are going to go looking for that know what an IP address is, a MAC and an EMAC, and they can figure out that, yeah, if you log on with your computer, they're going to figure out who you are and follow you around or something. But they teach you most of it. They teach you what a gun type nuclear weapon is, where you have basically it's like a pipe bomb. At one end, at each end, you have some explosives that create a shock wave on each end that go from end to end and collapse on the center, where you have two sources of your uranium or whatever, and you have these explosives that push in on it and slam the things together, and boom, right? It creates fission in the same way as in a reactor, kind of. But they don't explain everything. They do explain what kind of neutron you need to put in the bomb based on experiments that were done on some sand they recovered from Alamogordo, New Mexico, where the first test was done, which was called Trinity. They picked up the sand, and inside the sand was various products from the explosion, some of them being the neutron. The neutron is just like in the reactors. You got to figure out yourself, because they don't explain it, how to get the neutron to bond with the uranium or the plutonium or whatever you're using to make it unstable so it'll create fission. Fission is division. Fission that splits and splits and splits And in the very small space that it's in, it creates extreme pressures and blows up, right? So it implodes and then explodes. And the pipe bomb is the crude one. They didn't test that at Alamogordo before they dropped the bombs on Hiroshima and Nagasaki. One of them was the pipe bomb. The implosion bomb was tested at Alamogordo. That was the gadget. That was the Trinity test. And that is where Oppenheimer quoted Arjuna from the Gita, and he said, "Now I'm the destroyer of worlds," and all that. That was that test. And the Trinity is the Father, the Son, the Holy Ghost thing. Is Alamogordo, Hiroshima, and Nagasaki. Right, guys? Anyways, you listen to the video, they'll tell you what kind of neutron source you need in your nuclear weapon, right? I'm not going to give you a recipe, but I'll just tell you it's out there. It's also what A.Q. Khan in Pakistan explained already. And the implosion device is a little bit more sophisticated. You have to have a soccer ball design, and you have to create a spherical shock wave that collapses on the core so that it applies pressure in all directions at the same time in the same proportion on the center to create that fission in the middle, right? And you have to have the neutron firing into that center, and I guess you might need a moderator too. It's somewhere in there. So I don't know, use silicone like a breast implant. That's my joke. Or you could use water in there. I don't know, but you'd have to seal the plastic and the neutron from the water with maybe something like silicone, like a condom or some rubber gloves, some latex or something. I don't know really how that all works, but I do know how to disarm the bomb based on how they build the bomb. And the way they build an implosion device, and it's important for law enforcement, if our communications were ever cut off by an EMP, and we had a WMD out here in St. Lucie County, or, there's a lot of rich people out here. There's West Palm, there's Jupiter Island, Vero's got a bunch of billionaires up and down the Treasure Coast here. There might be a reason somebody want to blow us up out here. But if we had a bomb out here, the way you blow it up, I'll explain how to disarm it first. You have this bomb, it's a big round ball, looks like a huge soccer ball. Well, it's encased in case-hardened steel like you might find in your gun safe or something like that, right? Why? Because you want the explosion to go in on collapse on the core. And that's important. You have to create that shock wave that goes in, not an explosion that goes out, right? So how do you do that? Well, you have to create some space on the inside for it to collapse on, and you have to put some explosives in there. And what's going to happen if you put explosives inside of a safe? Is it going to blow up the safe? Well, if you line the walls of your safe, and it was a round soccer ball safe, and each panel of the soccer ball was lined with explosives, first it would implode on the soccer ball, as long as the soccer ball was like in a big safe, a big round safe, right? Why? Because it's going to take the path towards the core, which has less countervailing forces. That means it has less, think of it as resistance. If I'm pushing against you, and you're pushing back against me, right? And I go like this and release my force, you're going to come this way because there's less force pushing against you that way. And it's the same thing as inside the bomb. The outside is all that case-hardened steel, so the easiest way for it to initially go, in the initial milliseconds, microseconds, nanoseconds, whatever, is going in where there is nothing. There's just a ball in the center, and then there's some empty space around. And in Kias, probably you need some empty space for it to collapse in first before it blows the safe up out. Yeah, and the explosives probably blow that safe up like a hand grenade. But first, you want the chain reaction to occur. And you want it to go not like a thermite hand grenade or something, but more like a much more destructive force like a nuclear weapon, right? Like, instead of like a ton of dynamite or, eighth of a ton of dynamite, 100 pounds of it. You want to blow it up like 1,000,000 tons or 100,000 tons. That's what a nuclear bomb will do these days, right? Anywhere from 10 kilotons all the way up to 5 or 10 megatons. Our biggest one's around 5 megatons. So, and we have dial a yield on some, and we can change the yield based on different designs we have that allow us to introduce more or less chain reactions in a thermonuclear weapon, right? So if we just use the fission bomb, we get one yield. If we start adding other elements to it, like a hydrogen one, the first chain reaction of hydrogen, then you get thermonuclear yield 300 megatons, or 300 kilotons. And then you add another chain reaction, and it keeps going, and it's like an amplifier. The only thing you have to do to take those out of there is you just don't send a charge or something, and you can discharge whatever you want, exhaust it, whatever. I don't really know how that control works. There are nuclear weapons controls that do that. They're just adding or subtracting an element of chain reactions. And that's with electronics and mechanics, electromechanical controls. But what you can do to disarm a weapon is you need some explosives. An artillery shell would probably do it. You could use TATP, some composition, large quantity of nitroglycerin, anything that's going to punch a hole in a real big, strong safe would do it, right? And you want to make sure your force is projected into the weapon, and it's not going to blow the weapon up. It will blow all the explosives up. It's not going to detonate the weapon and cause a fission bomb. It will blow the explosives up, but because it's not all simultaneous and creating that spherical shock wave that collapses on the core, then you don't have nothing to worry about except for a large environmental disaster. I say a large environmental disaster, I mean you're going to have big problems. It's going to contaminate the earth around it, the air, whatever. It's like a dirty bomb. So you want to put it inside of a tank or inside of an armored vehicle. And you want to put that armored vehicle in the ground or in a bunker, preferably. A building's okay, a hangar's okay, but it's going to blow up the hangar and create radioactive dust at your airport. You might want to put it in that. Airports are usually built on pretty crummy ground. They don't sell real estate out there. They just build runways. You can go build a bunker in a year that will satisfy your needs. And every county in America should have that. You should have your armored vehicle, your National Guard, or your state police or your police, some kind of armored vehicle. You drive it out there, drive it down into the ground, close the top, and detonate it. And put as many artillery shells in there as you want, as long as you don't blow a hole in your bunker. What you want is to blow it up and have enough of the force to exhaust into other chambers adjacent to your bunker, right? So instead of blowing a hole through the roof and out in the atmosphere, you want it to go deeper into a mine shaft, right? And each mine shaft has enough countervailing force to slow down the bomb, but not change the direction of the explosion. So it explodes down into the mine shaft, down through the bottom of the armored vehicle into the mine shaft, right? What I'm saying is you can create a series of chambers below your chamber that have doors below, and it blows a hole down, and then the explosion spreads out into another chamber. And what does that do? It takes away the force. It's attenuating the force of your bomb at each level. Now if it was too strong of a countervailing force into each chamber, instead of going down into your chamber, it would go up out of your chamber, right? Because it will take the path of least resistance or the least countervailing force. If that's up, it'll go up. If that's down, it'll go down. So you drive your thing down in there and you want it to blow up down into a mine shaft so you contaminate the mine shaft. As long as you're not going into the water, in the riverbed or some kind of underground water table, you should be all right. You got a contamination problem? Sure. It's a big cleanup problem. You're going to have to pull all the concrete out, all the earth. And that's what I'm saying, the water table is important consideration. But you pull it all out, ship it somewhere, and it's an environmental waste. It's a health physicist's job and a contractor to do that. But a nuclear weapon, a spherical one, is a soccer ball design. The basic design is the outer thing is a case. As a men's question, they ask security at the Department of Energy in places like Caltech, MIT, Georgia Tech, Princeton, places like that, in the physics and math department. They ask you where do they keep all the nuclear weapons? They keep them in a safe. This is a joke once you figure it out, and some people have to do the physics to try to understand, and then they have to make the jump. Once they understand that there has to be a nice hard shell around that thing to get the force to go in, then they have to figure out how to design that. Then they have to make the jump to what is that? What is it compared to? And you need to prompt people usually in college, because they've never seen one. And some of them will look up pictures and things, and they just don't make the connection between a weapon safe, a gun safe, and a nuclear weapon safe. And the one that will get you and that will drive you all the way down the path to the answer is to look at the SADM. The Special Atomic Demolition Munition is a backpack nuclear weapon that's built in a little safe, basically, and it has a combination lock on it that you have to open to arm the weapon. And you parachute in with these things. SEALs was going to clear beaches during the Cold War, and I was the commander of the SEAL teams that did these things. And we worked with the Army engineers, the Army Special Forces, and the SEAL teams on recruiting people for these missions and training people, and Delta Force and Army Green Berets, and there were special Army engineers called Green Light teams. It's all they trained for. They did a lot of running, a lot of push-ups, a lot of sit-ups and all that. And they was going to carry this 50-pound backpack in with one mission, was to blow up the Fulda Gap in Germany, or parts of the DMZ where they had a lot of artillery, or the SEALs would swim in with one and take out a beach for the Marines. It's going to be a lot better than naval gunfire. It's going to clear the beach, be able to run right through. There will be no resistance. We take out guns, whatever we needed. Guns, troops, booby traps, all that would be gone, right? Because you put a mine in the beach and we blow it up with a nuke, there's no mine. The shockwave will blow up all those explosives and shit. So it only tested in the desert once or something, but it was ready to use it, and it's still an effective weapon until we get the hypersonic nuclear weapons that travel at 4,000 or 5,000 miles an hour and carry a small nuclear weapon, tactical nukes on a Tomahawk or something like that. We don't need a SADM, but the Special Atomic Demolition Munition was a small safe, and if you look at it, there's a video from SANDIA, Sandia National Labs, and they're out in Albuquerque at Kirtland Air Force Base or something. They show an old stock footage video or whatever on how to parachute into the water with one and swim into the beach and place one or something. And they show it in another video, I think they show how to arm it, and that's where you see it's a safe. And that's where you'd get your information if you were a spy in Pakistan or India or Israel trying to figure out how to put one together for their army. You'd start doing open source information and talking to GIs, and it will be no secret because it's on YouTube, right? And even if Sandia didn't put it on YouTube, the Russians did, or the Iranians, or the Chinese, or somebody, right? And it's not hard for an Iranian physicist to figure out how to make one. It's got a soccer ball, spherical shockwave you have to create. The way you create it is with explosives in each panel of the soccer ball. What's on the outside of the explosives? On the outside, you have charges. You have blasting caps. And then you need a series of wires to the blasting caps and a circuit. Well, the part of the circuit you put big capacitors right on the outside of the blasting caps. And what is a capacitor? It's like two plates. When you apply current or electricity to it, voltage, you're going to charge the capacitor. And what is that? Well, there's a dielectric between the two plates, which is a gap, like on a spark plug. And a spark plug is like a capacitor. And it charges each plate, one negative, one positive. And then when you discharge it on a circuit, it will send a current into the circuit. So it's like kind of like a battery. It charges and discharges. And so you charge it up, discharge it, it blows the blasting caps. The blasting caps blow the explosives. The explosives carry the neutron into the core and create that fission bomb, the fission reaction, which explodes inside that contained area and creates pressures that are many magnitudes greater than the sun. And I don't want to quote any numbers, I'm not an expert. Much hotter and much more pressure than the sun. Okay? And so how do you create a spherical shockwave like that? It sounds easy. You just line it up. No, it's not easy. It's very precision work. It involves like a very good calibration technique, lasers, and you know, back in 1945 they didn't have the stuff we have today. These days almost any country around the world can get what they need. They have surface plates that make things flat, so you get and some things don't need to be flat, right? There are things that need to be flat in there, but the curvature of the explosives, the curvature of the blasting caps, the curvature of the capacitors, and all the components kind of have to fit together like a real intricate puzzle, where the pieces have to fit just perfect, right? And that involves a lot of machining and calibration, calibrating the machines and then machining pieces that are perfect. And how do you do that these days? It's much easier with 3D printers and all that, lasers and everything. It's not difficult. They can build them in their backyard if they have the fissile material, the weapons grade uranium or something. How do they get that in the United States? It's pretty easy. You just bring in $250 million worth of drugs, then they got cash, they buy an ounce of uranium or a gram or something. However much they can get for $250 million. It's probably at least a gram, and a gram is 1/500th of your weight to a pound, and you need 12 pounds, right? So if you need 5,000 grams, is right about what you need, 5,000 or 6,000 grams to make a nice bomb. You would need 5,000 times 250 million, right? So it's 500 million times 100 or something would be 5 billion, 50 billion. Probably, yeah, you would be a pretty rich guy. It would be in the billions to get enough uranium to make a bomb. Even Kim Jong-un would want a good 10, 20, 30. He'll give you a discount on an order like 12 pounds. But yeah, he don't want to be as rich as Bill Gates for sure. He's a rich guy anyways, you know, has his kingdom. But another 50 billion? Some people wouldn't blink, they'd hand it to you. As long as you could deliver the gold bars or whatever. But, so yeah, you have to machine the parts perfectly, and then the triggers have to all go off simultaneously in the perfect direction. So there's a lot of calibration and alignment in fitting the bomb together once you have the pieces. But, and then a circuit that times everything perfectly, right? Because if you have one panel blowing and the other one's wait a nanosecond, it might be enough that that thing's going to fizzle instead of pop. And you don't want it to fizzle, right? We don't want it to fizzle. We don't want it to pop. We want to catch some drugs on the border and everything. There's a reason for demilitarization and the border security. It's nuclear weapons. The nuclear weapons, they're available, and we have to do something about them, And what I would say is the thing is about the bomb is disarming it. You just have to know that you're going to punch a hole in one side. Any corner, side, whatever you want to call it. Find somewhere where the core is at the center there. You can x-ray it if you want and whatever to find a good point of entry to the bomb, not to the circuits and all the missile or whatever else. You want an entry to a bomb. It depends. If it's coming out of a missile or something, they dropped it off on our shore, that's one thing. It's usually not going to be that way. It's going to be something they smuggled some uranium in and built something here, right? Well, that thing is, with the amount of fentanyl that comes in the country and meth and cocaine, there's enough money in this country and overseas to buy the components. And there are some crude nuclear weapons that they don't even need a nuke. They just use computers. Get enough supercomputers and what do they call those things? Clusters. A cluster is a bunch of PCs they put together into a formation that's like a supercomputer. This create a bot war of 1 million of those things, or take over parts of SETI or something like that, or folding at home, or one of those other large. It's like a cluster, but they're looking for aliens or whatever. Yeah, they want to hack those things and use those for their computing capabilities. There's a bunch of spies try to use those. So people contribute their computer. So, man, I'll take control of that thing. You don't need to worry about looking for aliens. I need to do some math for my physics project. And they're former KGB, FSB, the Russians. And they want to do bot war and fake news and everything else using SETI or something. But anyways, how do you do it? Punch a hole. When you punch a hole, it's not going to create a spherical shockwave. There's a lot of physics and math into creating that shockwave. What do you need to know? It's called a wave equation. And you don't learn about wave equations in your freshman or junior year of college. Unless you skipped it all and went to your freshman or sophomore year. Usually it's in your junior year in a class called, what? Partial differential equations. They teach you wave physics and they teach you heat physics, and both are important for nuclear weapons. You're going to need to know the wave equation and the heat equation, because the heat affects where that wave is going to go to, right? It's going to affect the structure of that steel around the bomb. You need to know the timing and everything, when that wave is going to get to the center. You want to get it going, and you want to get it going so it's headed to the center, because the outside's going to blow. It's going to pop like a pineapple grenade, right? But before that happens, you want the wave to be going inside. So the wave equations, partial differential equations, generally in college you take Calc 1, 2, or Calc 1, 2, and 3 at some schools. Then you take... at some point, you're going to take chemistry 1 and 2. You're going to take physics 1 and 2. If you're a math major or a physics major, you're going to take probably some vector stuff and also some partial differential equations in your junior year. Maybe some statistics or something. That kind of stuff's helpful too. And you take quantum physics in your junior year or senior year. Quantum physics is where you're going to figure out a lot of that, because quantum physics is about the waves and all that kind of stuff too. They want to teach you the Schrodinger equation and all that kind of stuff. So where you learn some of that stuff, that theory of relativity, special relativity, general relativity. You learn all that, and you can put it together. Then it's all in the classes that they teach in the physics and math department. You go to the Belfar. It's like BELFARE or FERE or something. Belfar Center. I'm not sure that's about FAR maybe. At Harvard, they have YouTube videos, and they'll tell you all the materials you need and how to construct one. I'll tell you how to disarm one. You're a cop, you need to know. As the reason I say you need to know is somebody could attack us with cyber or with an EMP. We wouldn't have communications with Washington command centers. The JTTF could be disrupted. Your WMD expert might be locked in a cave somewhere and not want to come out and not want to help you because he's alive and he doesn't want to come out here and die with you. And he doesn't want to be assaulted, killed, whatever. And nobody else wants to get out of the bunker either. So you're where you are. You're a cop out at the police station. Yeah, he's a pussy. He pussied out in the moment of truth. And what do you have to do? You've got to go find the EOD guy. And you got to blow a hole in a nuclear weapon you guys found with the Marines or with the Rangers or with the National Guard or whatever. And you put it in a tank, and then you put that on a flatbed truck so nobody has to drive around with the thing. You fly your Apache support and your F-16s down the highway, providing close air support in case somebody tries to steal it, because that's what they'll do. And you have the Highway Patrol and the National Guard block every entrance and exit to the highway till you get to that little pit in the ground you built for the disposal out by the airport somewhere, or the city dump or whatever. And what are you going to do? If you don't have a pit or a bunker, you're going to build one real quick with some explosives. You just dig a hole with explosives, clear it out with a what do you call it, a dozer, and drive that thing down in there and cover it with dirt and blow it up. It'll smolder probably, but not going to have as big an environmental problem. So the reason you use the tank or the armored vehicle is for containment. Containment is the key there. And you need a containment vessel. Sure, you definitely need a containment vessel for nuclear explosions. If we could put every dirty bomb in a containment vessel, we wouldn't have a problem. If we could have a big enough one for every meltdown in the plant, we'd be covered. As long as the containment vessel didn't go and melt down or blow up, we'd be covered. But not everything's designed the way it needs to be designed. We think about things later. More supercomputing now. We have more safety protocols or whatever you want to call it. So it's better now, but it's still not good enough. Yeah, you just punch a hole in it. The problem I'm telling you is the inside's radioactive. And I told you it's going to be like a dirty bomb. All that explosives on the inside is going to blow its way out. And then it's going to, even if you just punch one hole, it's all coming back out the hole. And it's actually probably just going to blow up, and the whole safe will pop like a grenade. You're not going to want to be standing around that thing. You might want to know how much explosives is in there, so you know how much shielding you need and how much space you need between you and the bomb. It's probably a fair amount. And then it's going to be a lot of radiation. What is it? It's alpha. You need an alpha suit. It's this paper suit. It's any other kind you want. Concrete, wood, and lead between you and the bomb, or the radioactive waste, because that's gonna fuck you up. Gamma is just travels. Gamma will travel long ways and go through a lot of things, but lead and stuff is gonna help you. A lead shield. When it comes to beta, it doesn't travel as far. You need some glasses. You don't want to blind yourself. Yeah, and gonna use those militarized vehicles that Donald Trump gave back to you. Obama wanted to take them away from you. Quite understand what they're for. And some of you don't either, because you don't work for the National Nuclear Security Administration. You know, yours truly here to help. Have a nice day. Semper Fi, anchors away, never leave a friend behind.